folks. I'm Ruth Berman, Director of Delivery at Code for Canada, and welcome to the Canada Case Studies. Just before we begin, Forward 50 takes its code of conduct seriously, and we're trying to ensure that we keep this a safe space for all. So please keep it clean in the comments as we all interact with each other. So just getting back into it, Code for Canada helps governments and communities harness digital by using emerging technologies. And we do this by offering several services to our government partners, including user testing with diversity inclusion as a core focus and at the foundation. Digital transformation training and fellowship programs, which is what you're going to be seeing today. The fellowship itself embeds digital professionals into government, and our fellows are super passionate about solving these complex issues and to work with our partners to solve them through emerging technologies, evolving their agile practices and design thinking practices as well as offering bespoke training to make sure that all of that sticks. So without further ado, let's get into it. Our first partner, Employment and Social Development Canada, delivers so many critical programs to Canadians, including some of the most well-known. For example, Canada Pension Plan, CPP, Employment Insurance, or EI, as well as maternity benefits and many, many others. Our mandate was to help make the way that it delivers maternity benefits easier for Canadians. Our fellowship team did this by creating a chatbot, and I'll hand it over to Team Babel to show it off. Thanks, everybody.
Hi, everyone. Thanks for taking the time to be here with us today. In the next 40 minutes, we will tell you about our team, who are on the screen with me, the problem we were assigned to work on, how we went about creating the first policy difference engine. We will definitely show you the thing, and we will wrap up the challenges we face and the lessons we learned along the way. We were known as Team Babel. The three of us were from Cohort 5 of Code for Canada. We began working at Employment and Social Development Canada, known as ESDC, in December of 2020, and our fellowship ended in August of 2021. We were a team of three. I'm going to pass it to Sidra and Regan to do a quick introduction.
Hi, everybody. I'm Sidra. I now work at ESDC as a design lead, but prior to this role, I worked for the last 9 months with the amazing Team Babel.
And I'm Regan. I was the developer on Team Babel, and I'm actually currently back at school attending U Ottawa for a master's degree.
And my name is Dana. I was the product manager for Team Babel. Like Sidra, I'm currently at ESDC as a product owner working on a brand new and exciting product. One of the things that helped us as a team connect and work well together and also succeed in our fellowship was our alignment on team values. We deeply believed in working in the open, and we did work in the open as much as we could. We utilized the Scrum principles, built our work in increments, showed the work frequently to receive feedback, to reiterate and improve. We built capacity about our product, about our approach and methodology, and about the fellowship as well throughout the 9 months that we were at ESDC. We championed user-centric design, digital transformation, and sustainable transition of the project. I'm going to switch gear now and tell you about our problem space. Let's consider the following scenario. Your team was asked to build a chatbot for the maternity policy. On the long list of tasks that your team needs to complete in order to create this product is codifying the policy itself. This simply means transforming from the legal language or the rules into the coded version so we can interact with it. To go from the human version of rules, in Canada it's available in English and French, to its machine-readable version, we depend on quite a few important people. Doing this exercise well means dependency not only on policy experts to help us correctly understand the policy and its intent, but also on developers to help us assess the readiness of the coded piece. It's an exercise that's best suited to include people like service designers, really great project managers to scope the work, and other subject matter experts to guide us along the way. It's the work for an interdisciplinary team. In an organization with a large backlog of products and projects that are almost all policy dependent, delays become inevitable when we all rely on the knowledge and expertise of a relatively small team of policy SMEs that work in different ways, usually across silos, with varying levels of complexity in their analysis. The experience can be frustrating, and by design, we gradually lose the agility needed to deliver services. Under the current ways of work, we also face inconsistency in implementation of the rules. Consider the following two scenarios. Two different teams working on two different products for exact same policy. Chances are these teams end up working with different policy experts, and therefore, the coded version of the policy for each of these products becomes slightly different than the other. Under this scenario, we also face another challenge, managing the impact of a policy change on our products and services. Regardless of the size of change, these products need to go through policy update every time there is a change in the policy. And so yet again, we are back at the game of being dependent on a small team of policy analysts who need to help us understand the intent of the policy, codify it correctly, and test it in order to run our products and services effectively. Let me give you a quick recap of our problem space. With the current design and workflow, the system does not have the agility needed to create, ship, and maintain policy-dependent products in a timely manner. Implementation of rules is not consistent across the government because we work with different policy teams. And a change to the rules can add considerable stress to the system because all these products and services need to go through that update of a change. Our proposed solution to address all these problems is changing the way we work. What if, with the help of a diverse team of policy people who can ensure that we translate a given set of rules as accurately as possible, we create something called a rules as code engine. This engine will hold the machine-readable version of our rules. Nothing more, nothing less. This code can be used by any application that has dependency on that rule. This infrastructure drastically reduces the dependency of a high number of products on a small team of policy people. It creates efficiency, it introduces agility, and allows us to have consistent implementation across all our products and services. On this note, I'm going to pass it on to Regan, who is going to tell you about the rules as code in more depth and show the work that we've done.
Right, thank you, Dana. So I'm going to go into some of the technical details on this rules as code engine idea. Then I'm going to discuss one of the many applications of the rules engine that Dana had explained there, the policy difference engine. And we'll show two working examples of this idea in action. So the rules as code is, think of it as a single source of truth for a rule. And here by rule, we mean government policy, regulation, or legislation. We can think of this engine as an independent piece of software, for example, a REST API. And since it's a single source of truth, we need to make sure it's correct. And since these are government rules we're dealing with, that means we need to collaborate with the government experts. So people who study these rules on a daily basis. And as Dana explained, this collaboration is a challenge. It's also an iterative process, like much software development is. So suppose we have a rule that specifies entitlement for some government benefit. You're going to give this rule engine some information about the applicant, so maybe age, income, employment information, etc. And then the API is going to tell you if this person is eligible, or maybe how much they're entitled to, for example. So suppose we have this API. We've done our collaboration, we have an API. This on its own isn't directly useful to an applicant. It needs a user interface. So this could be a mobile app, a website, or as Dana explained, a chatbot. Once we have the API in place, we can use it for all sorts of these applications. reusability of a system like this is a common goal in all software development. So the application that we want to focus on here is the policy difference engine, or the PDE. So at a high level, it's a tool that can help measure the impact of a change to a government rule. So naturally, we need the rules engine sitting behind it. We contributed to 2 PDEs for 2 different rule sets over the course of our fellowship. So let's walk through them. So the first one is the motor vehicle operator hours of work regulations. So this work in the area of rules as code had been happening at ESDC well before we arrived there as a team. And as we were doing some initial research into our problem space, which was centered around maternity benefits, we were invited to join in on this collaborative process with experts where the written government rules were translated to code. So the rules in question was this motor vehicle operator hours of work regulations. It's a mouthful. So what this deals with is if you're a motor vehicle operator, you want to know how many hours of overtime you're entitled to on a weekly basis. So you're going to, this is going to be based on like how many hours of work, how many hours you work per week in different categories. So as a highway operator, as a bus operator, as a city operator, etc. So it's a fairly complex calculation. It's not trivial. And the written legislation or written regulation has a lot of legalese in it. So it can be quite complex. So there is a desire to turn this into something that is machine readable so that we can build these applications around it. Here's a link to the regulation itself. It's not too long compared to some other regulations, but as I said, lots of complex legalese in there that can make it a little bit difficult to interpret. Okay, so if you're a motor vehicle operator, you want to know how much you're entitled to. It's outlined in these regulations, and we want to automate these, or we want to turn this into something that is machine readable. So through this large collaborative effort between many different organizations, so the ESDC, ourselves at Code for Canada, the Community of Federal Regulators, Department of Justice, Canada School of Public Service, we built out this rules as code engine. We exposed it as an API, and we built a policy difference engine on top of it. So if you're a policy analyst, you may want to study this regulation. You may want to change the regulation. But we need to know how a change might impact the people that the regulation targets. So in this case, it's the motor vehicle operators. So suppose we have the schedule of a motor vehicle operator, and we can find out how many overtime hours they get based on the schedule and information that they give. But if we change the rule, we can also see how much they would get under the proposed change. This is the essence of the PDE. So we have the encoded rules that we can alter to represent a proposed change. So we have 2 sets of these rules. We have our data, which in this case is going to be a schedule for a motor vehicle operator. We have a simulation engine, which is going to bring those 2 pieces together. So it's going to run both sets of rules on our population of data, and we're going to get 2 results, one from the initial set of rules and one from the proposed change to the rules. And then we can aggregate those results and visualize it in a user interface for policy analysts. So this is the basic pattern of a policy difference engine. We're going to see the same pattern with the second policy difference engine that we look at as well. But this is the first one. So let's look at a demo. Let's look at the web application in action. So here on this screen, we have schedule of hours of work. So this is our data portion. This is where a policy analyst could go in and they could enter a mock schedule for a fictional motor vehicle operator. You could also imagine a scenario where we import a bunch of real schedules about motor vehicle operators from an actual database and bring those into our system. Since this was a short 3-week sprint, we were just proving out the concept. So in this case, our data is just simply one schedule here that you can edit. So we enter this data here. So this is like city motor vehicle operator. So how many hours they worked as a city motor vehicle operator. how much they worked as a highway motor vehicle operator, and this is other. So this could be working just as a bus operator, for example, or anything else that doesn't fit in these other two categories. So this is their weekly schedule. It aggregates, it shows how much they work per day and then how much they work in each category. So this is the data that's going to be input into our system. Then down here, we have the rules. So the rules, when we went through this collaborative effort and encoded these rules, we extracted all of these numbers from the regulations. So for example, there's this standard city motor vehicle operator daily hours, which is at 9. So for example, if you exceed those hours, then you're going to be entitled to a certain amount of overtime. Again, it's a fairly complex calculation. So let's say we change some of these thresholds. So these are the existing ones on the left. And then on the right, we have the proposed changes. So let's say we just change these two right here. We change the 9 to an 8 and this 45 to a 40. So we're making some slight changes in the rules. So we have two rule sets. We have our existing rules, our proposed change, and we have our data. So now what I'm going to do is I'm going to run this. And when we run this, it's going to take both of those rule sets. It's going to run our data, our schedule, against the first rule set, calculate the amount of overtime that they're entitled to, and it's going to run it on the proposed change and calculate how much they would be entitled to under the proposed change. So in this case, as we can see, under the existing regulation, they get 5 hours of overtime with this schedule. Under the proposed change, they would actually get 6. So a slight difference there. So you could modify that. You could enter in different hours. You could see how much they would be entitled to under a change. Again, if you had a whole database of existing schedules, then you could aggregate those results and you could see, like, on average, how many overtime hours are people gaining or losing, etc. So this is the idea of the policy difference engine. The policy analyst can run these simulations, enter the data, and analyze the data and see what the impact might be. Okay, so that is the example for the motor vehicle operator hours of work regulation demo. Now what we'll do is going to move on to the maternity benefits policy difference engine. So the motor vehicle operators one, this was our team's first hands-on experience with building out this rules as code engine, turning it into a policy difference engine. It was a 3-week sprint. This policy difference engine was one of the artifacts. We learned many lessons from this, and then we took those lessons and we applied it to our main project, which was a policy difference engine for maternity benefits. So we're going to go through this one in a little bit more detail. We're going to start with the maternity benefits calculation. So let's say we have somebody who is entitled to maternity benefits. We want to know how much they are entitled to. So in order to find this out, we need some information about the applicant. We need to know, for example, their income, and we need to know things like their postal code. From this raw data, we can calculate an average weekly income, which is ultimately, it's going to be based off the record of employment. So we get their average weekly income. Once we have that, these are the steps we take. So first we take 55% of that income. We compare that 55% with a maximum value of 595, and then we take that. And so if that 55% is above 595, then we put that limit of 595. If it's below 595, then we stick with whatever that number is. And then we're going to take that result and we're going to multiply it by the max number of weeks that you can be entitled to, which is 15. So we have two examples here. So person one, their average income is 1,000. Take 55%. You compare it with 595. It's lower than 595, so we stick with 550. You multiply it by 15, and this is how much person one is entitled to. With person two, same process, and this is how much they're entitled to. Okay, so that's the entitlement amount for two people. Now say we want to propose a change. So these right here, this is just a simplified version of the rules for the maternity benefits calculation. Let's say we want to propose a change to those rules. So there's like endless amounts of changes that could be proposed to the maternity benefits calculation. That could be deeper structural changes, but for the purposes of our proof of concept, we want to limit the changes that can be made. So we limit it to these three factors: this percentage, this max value, and the number of weeks. So let's say we propose a rule that changes those three values. So instead of 55%, you take 60% of your average income. Okay, so maybe you get to keep a little bit more. But at the same time, we're going to lower the maximum amount from 595 to 500. So if that 60% goes above 500, then you're capped at 500. And then we're also going to say instead of 15 weeks, you can claim for 16 weeks. So we're pulling all of these levers here, and we're going to see how it impacts these two people. So person one, their new value is 8,000. So they actually have lost money. They lost $250 as a result of that change. Person two, they actually gained quite a bit. They almost gained $1,000 from that change. So this rule affects these two people differently. So two people is interesting, but what is much more interesting is if we can do this measurement on thousands of people, then we get a very much clearer picture of the impact of this proposed change. So if we run the change on 1,000 people and it turns out that everybody in there ends up losing money, then we probably want to rethink that change, right? So this is the idea. This is what we're looking for with the policy difference engine. And furthermore, if we have data on those thousands of people, say we have demographic data as well, so like age, province, education level, then we can see how it impacts those different groups. So do people from a certain province, are they disproportionately affected? Or are people with a certain education level, do they tend to lose money a lot from this proposed change? So that's what we can do with the policy difference engine. So let's look at a demo for that. Okay, so over here, this is the web application for the maternity benefits policy difference engine demo. So we have our three factors here: the weekly amount, the percentage, and the number of weeks. Notice we don't see anything like the data here, because in this case, the data is actually stored separately in a database of 1,000 randomly generated individuals. So it is completely randomized, but it is a proof of concept, so we could use it against real data as well. So let's make those changes that we proposed. So these were the three numbers. And when I run the simulation, it's going to do the same idea as we saw before. It's going to take those initial set of rules, those initial numbers. It's going to run it on those 1,000 individuals. And then it's going to take those 1,000 individuals and run them on those new rules. So the proposed change. So this one right here. So this results page is a summary of we see the summary of our two rules: original, proposed. And then we can see some overall results. So overall, this entitlement change was $156. So on average, people gained money. Of the people who gained money, on average, they gained this amount, almost $720. Of the people who lost, they actually lost almost $800. So we can start to see some of these numbers to help the policy analysts who are proposing these changes gain some insights into their proposed change. So furthermore, we can look at the aggregation by this different demographic properties. So we can look at by age, by province, by education level, and by income level, and we could do it by more. As long as we have that demographic data, we can aggregate by it. So suppose this change, we decide maybe this change looks pretty good, but then we aggregate it by province, for example, and maybe we notice that, hey, in Newfoundland and Labrador, 50% of people actually lose money from that. Whereas in Manitoba, 71%. So maybe the policy analyst, depending on their policy goals, that might seem unfair. So it just gives more information about the potential results of the change. So we can look for those aggregations by province, again, by education level. So maybe we notice that, hey, people with primary elementary education level, they seem to be gaining more so than some of these other groups. So it just gives you some more information about that. So that's a snapshot of what the policy difference engine can do. And that is the second example with maternity benefits. And I just want to emphasize that although these are very different domains, the motor vehicle operators and the maternity benefits, it follows a very similar pattern. You start with that data, you have your encoded rules, you propose change to the rules, it goes through that simulation engine, you get your 2 sets of results, and those get aggregated for analysis by the experts. And then finally, just a quick overview of some of the technology and some of the best practices that we employed while we were working on this. And so now I'm going to pass it off to Sidra.
Great, thanks Regan. Hi friends. So I am going to close things off a little bit, and to start, I'm going to summarize our project to give you a sense of where we were along a product roadmap. So to summarize and where we landed, we basically broke things down into 4 stages over the 9 months of our fellowship. We started with research and discovery because in order to better deliver a solution, we must understand the problem. Jenna would often say, we are the only PDE species in the galaxy because frankly, the policy difference engine was just a conceptualization prior to us diving in to start to build a prototype for it. So we really knew that we needed to better understand what our government partners' expectations were with something so experimental, what we'd be able to deliver realistically, what technical supports we could leverage in our delivery, and ultimately what was really feasible for us to build in 9 months between the 3 of us. So like we showed you, we delivered the first prototype using maternity policy rules, where we simulated a dummy population of 100 people and demonstrated the feasibility of both the rules engine and the simulation engine delivered in a front-end package. We then shared the wealth by working with the Motor Vehicle Operators Regulation Sprint, with the Canadian School of Public Policy, and the long list of folks that Regan mentioned earlier. There, we immersed ourselves in domain knowledge around motor vehicles and labor regulations to iterate on our prototype. And finally, we closed off our fellowship by creating the second iteration of the maternity prototype, this time with real anonymized data. So we improved on both the rules and simulation engines while ramping up our front end to do things like BWCAT compliant and with improved user friendliness. A lot of this work, while we're really proud of it, didn't come without its challenges. So we experienced quite a few challenges in our delivery of the prototype, but we're still very proud of where we landed. We delivered. The partner we were paired with at ESDC was in a relatively early state of digital maturity, so we had to bring in quite a few new processes without discrediting the internal beliefs and often kind of siloed and waterfall ways of working within large government organizations. Regulatory compliance is a requirement, so that means putting more effort into considering not just the privacy and security impacts of our delivered prototype, but their inclusivity, both to folks who speak languages other than English, as well as folks who live with disabilities. Direct access to user research was incredibly difficult, given the constraints of working on a fairly political, internal and innovation-focused experimental project. So we had to create a front-end user interface from scratch, essentially, given that the organizational design systems had just started to be developed. I mean, an analogy I would use a lot is kind of pouring the concrete for the foundation of the home while moving the family in at the same time. It's kind of what it felt like sometimes. We had significant challenges accessing real data that we mentioned for a litany of reasons, and had to perform significant due diligence to make sure that our partners felt confident and comfortable with the data sharing and the buy-in that we needed to deliver this tool successfully. Finally, rules as code is an emerging technology, and the complexity of legislation means that transforming rules into the code that we need to deliver technical transformation services, it's an extensive exercise, and it requires a lot of different domain knowledges, as well as viewpoints and a lot of stakeholder buy-in. So we're pretty proud to be one of the first within the Canadian government to experiment and prototype with this promising technology. So the next piece I want to speak about is basically what it is that we learned as a team. We basically learned that persistence is really important. There's a lot of pressure to succeed and to deliver. And if you don't, you end up becoming the topic of a case study, you don't want anybody to read about. So there was immense pressure, but at the same time, it helped that the 3 of us, really believed in showing the thing, like showing what's possible. So even if it turns out that there are specific regulatory constraints or political constraints around doing what it is that we thought we wanted to do, at least we had the opportunity to discuss with our stakeholders exactly what it was that we thought would bring them some benefit from a policy agility standpoint. We also made a lot of friends. We made a lot of allies. We worked with a lot of different departments. We even looked outside of our departments in order to perform user research on how to best perform policy analysis so that we can do it technically well. We worked a lot on building capacity. So each of us worked within the internal organization to take what we found and then deliver it in a message to other folks that worked within the organization to start to build together and to relieve some of the silos that often emerge. And then finally, we believed in the product. We think good policy analysis is really important. We poured through meeting minutes of ministerial meetings, for example, just to better understand what it is that people talk about. Regan talked about some of the impacts that we thought were really important, because oftentimes policy analysis is framed from the lens of economic empowerment, but there's so much more to consider. There's the consideration of the impacts on people who are racialized, or the impacts on people who are Indigenous, Aboriginal, and First Nations. There are a lot of considerations, and it's really interesting that when we're able to parse the data that we have with a prototype or a tool like this, we're able to actually hopefully and fundamentally influence policy in a data-driven way so that it serves people a little bit better. The other things that we essentially think that the PDE needs in order to evolve to the next level is we need to start really thinking about what it looks like to model interdependencies. Who can leverage our tool? Who can use it? We have a GitHub repo. The sky is kind of the limit, and we really encourage people to move forward because this is like very emerging and innovative technology. And then also applying the specific frameworks we constructed to other policies, because policy analysis development is never done, and it evolves. Even with the last election, like there were policy platforms that would have had a significant impact on a lot of our service delivery. So it's really important that we understand, what are the possible changes that might come up, and what are the potential implications on the people who are going to experience those implications. And to close, I just want to welcome you to stay connected with us. Take a look at what we did. We've recorded all of our sprint retros, so you can see us evolve and grow like a little tree at teambabel.ca. And then we've also got this great GitHub repo where you can peek around and learn a little bit more about what it is that we do. And it's got a ton of really great and detailed technical documentation. So I want to thank you all for joining us. This has been a pretty amazing opportunity as the three of us start to flourish in our civic tech careers. And I really encourage questions from all three of us. Thank you so much.
All right. Thanks, Team Babel. And thank you all for watching that. Just a heads up, you can actually chat with everybody in the Forward 50 Q&A room. Just click the link to join the team in Wonder. That will take you off of this platform and take you into the space to ask them questions directly. And we'll see you back here at 2:30. Thanks again, everybody.